Okay, my friends, hold on tight because you are about to be rocked. They just brought back a sample from this asteroid called Bennu, and they are going to analyze it. Before they analyze, I'm going to tell you precisely, and I mean precisely, what they will find when they analyze it. I'll show you right now. Get ready. This is going to change your life. Okay, my friends, the reason I can make these outrageous claims is because Bennu is a heart, and so is Psyche. They are virtually identical. You see the chambers of the heart? That's the chambers of the heart. That's what it is. Now, what is it made of? I can tell you precisely what it... Well, let me just show you what I found. All right, this is why I can be certain one way or the other if I'm right or if I'm wrong. This is blood that was donated by 106 volunteers, and these are all the different elements that are in the blood, their concentrations, all of this stuff, and primarily they're going to be within the periodic table in the transition metals, because these are the things that carry things around in your body. They have oxidation states, and they are the things that latch on. They call them with ligands. It's a chemical attachment, and then they go to somewhere else and they want 2 electrons. They drop them off and they pick up the carbon dioxide and take it off, deliver oxygen, pick up carbon dioxide, that type of thing. You're in a continuous state of change. Every molecule in your body is continuously giving up and taking on new elements. It's called nucleophilic biological substitution. There's nucleophilic substitution in just basic chemistry, but biological nucleophilic substitution is primarily breakdown of food and delivery of the food, taking out the wastes, breaking down the waste, and they use enzymes to do this, and the enzymes are created by the bacteria. So all of this is a web of life, and I will tell you right now, and I'll bet money on it, that this is going to be primarily exactly what they are going to find from these from the sample from Bennu. Now listen to this. This I found fascinating. They found that during the time period 76 to 1991, they concluded the major cause of the observed decline in lead levels was most likely due to removal of 99% of lead and the removal of lead from solder cans. Listen to how much it dropped. Mean blood level of persons aged 1 to 74 dropped 78% during the time period 76 to 91, and that's when they took the solder out of cans and they took the lead out of gasoline, and people's blood levels dropped 78%. So there's going to be some variation here in the quantities and different types of metals, because obviously they can be jiggled around a little bit, this and that, and I don't know what this blood is from, what kind of a creature it was, but I can tell you what, it's a heart, and it looks like it could have been just like our heart. It looks identical to me. So this won't be exactly the same, but these metals and so forth, they're pretty much all going to be there, because that's basically what blood's made out of. The rest is basically plasma, to give it into a fluid form, aqueous form, to drag it around the body. Okay, this is what's in blood. Now, these were from, I think, 106 healthy volunteers gave their blood, and they did an analysis of what blood consists of, primarily for metals. There was a panel of 26 metals, panel of 26 elements, and these are basically metal-ish, mostly metals. And here's what they did find, is these concentrations in these types of metals. And they did like 4 different types of panels. I don't know exactly, there's a lot of detail to this, but this is exactly what they should find. These are healthy adults or healthy people, and these are all the different factors. Now, something that really did turn me on here was this down here. Whoops. Hold on, I got to find it. See, they're sending a mission to Psyche, which is a metal asteroid, and that is another heart. Now already from the dust that they have retrieved, they really haven't looked at much, but they've already found clay, water, and carbon. We're carbon-based creatures. Water in the clay, and is inside the clay, is inside the tissue of the blood. And there will be plenty of moisture on there. That thing in space, they do not bleed their moisture off. It doesn't appear, because when they come into close proximity with the sun, they literally boil that moisture off into the atmosphere, and I can show you that very clearly. Okay, and I know this has got to be shocking to people that are not familiar with my work, but it is factually true, as I pretty much can present. Almost, look at this. Look at the architecture. Look at this. There's absolutely no difference whatsoever, and the same thing here. You see it? Look at this. Now, not only that, this little abrupt transition here, I know exactly what that is too. All right, so here we have the vein. Probably this is the used blood, and this is the new blood. I don't know. They're two different valves, and I believe there's another one down here, right here. Now, you see this ridge right here? I don't have a clear enough picture at this, but I tell you what, they have very, very close shots of this. They were right here on top of it. You're going to see this is going to be tendon. And you're going to say, oh, come on, how could you tell that? Well, here's how I can tell it right here, because this is what a heart looks like. This is an actual heart. And this is the tendon ridge right here. That stuff is the gooey stuff that just goes away. And of course, we saw the tubing at the top, and the gooey stuff goes away, and that ridge will be this tendon right here. Your heart has to do this 24 hours a day. Same things with your lungs. Now, this is what it is. And when they went down into one of these craters, which have a valve in it, so it doesn't, they all have valves, either go this way out or this way down, one way or the other. And so they went down into one of the valves, which is right down in here. I think they went right down into here. I'm not sure, it could have been here, but I believe it was one of these craters. And they went bang and then took right off again. So they went and grabbed and popped out. Grab and run. And that's what they did. Now, what did they get? Well, as far as I'm concerned, they had to get blood. This is no other option there. This is just almost 100% blood. All the other stuff is a little tissue. They might have got a little of that, but I don't think much. Anyway, that's what this is. And it's so obvious once you take a time to look at it and understand it. Like, I believe this is a valve going this way, and that's a valve going that way. But that would have to be looked at very closely, and I'm sure they have the pictures that could really focus in on this. I don't have access to that, but I do have access to this. It's the same thing, only this one is iron. Now, has already smelted. Now, what is smelting? Smelting means that it's been exposed to some enormous amounts of heat. And then it cooks off all I call it the cheap stuff, the lower molecules that they're combustive. They give off the gases and so forth, and it ends up being primarily metal. Now, normally you would see this metal meteorites coming through the atmosphere into Earth. And why would it smelt? Because it's hitting the atmosphere and it's literally burning up. You see them coming through, they start glowing red, and all of that stuff goes away. And I'm going to show you a lung. This is a heart, but creatures that have hearts have lungs. And this is a lung. And that is on here on Earth. That cooked up on its way coming through. And right there is a little red blood spot. You can still see, and there's red blood there. That could actually be tested. And what is that? That's a lung, same as this. And this still has blood in it, the red stuff. It's soaked inside, but it bled all of that stuff out into the alveoli, which means the fascia that coated it. There's a coating on the lungs, and that coats all of that stuff, and it's a big, like a rubber bag. Now that eroded away, and now we're down into the alveoli, all these little holes. And you can see that hole goes down into more cavities. They fed all of the holes in here just like they did on this one. Now this came through the atmosphere and it burned up all the cheap stuff, all the things that easily give off when you do smelting. Smelting just means to reduce it to its most heaviest elements, which are the metals primarily, and that's what that does. That's how they make iron, and they make all kinds of steels and so forth. Now, that's a lung, right? And it's here right on Earth. It's the Willamette meteorite, and I have one here that is a little tiny lung that came through space, and it is iron now, and it still has blood in it, which that one does too. Almost all of them still have blood in them. These iron meteorites, you think they don't have blood in them? Look at this. This is an iron meteorite. They cut it right down like this. I think this would have been a liver, because it doesn't have the holes and the chambers and all that stuff like a heart and a lung would, but it's still almost 100% blood, and that's what a liver would do. Now, you see here, look up there. You see that red blood? That's red blood. What's that doing in the middle of an iron meteorite? And guess what? That's black blood, because that's a vein and artery. The vein ends up turning into what they call magnetite iron, and this is hematite, the red. Now the red is what they use to make iron, because it's very easily, you can drive off all of the cheap stuff and turn it into iron much easier than this. Now all these different colors and crystallizations are due to the fact that you have all of those different metals I just showed you. Primarily it's all the transition metals right in here. You see it? Where is it? Yeah, transition metals are the blue ones. And then you have other metals, which are over in here. And that's all in here too. This is all used to facilitate the movement of chemistry in the body to do nucleophilic substitution, which means to give in, send in some nutrients and vitamins and this and that and magnesium and so forth, which they say, oh, you need this, you need this, you need that. Well, yes, you do. Well, how does it get there? How does it get there? First of all, bacteria has to break it down using enzymes to break down the stuff that comes into you, and then it turns it into whatever it needs to turn it into. Bacteria uses enzymes, a very, very elegant chemistry, but you have to have the right bacteria or you will be ill, because you will not end up with the right chemistry. That's a whole nother area that I delve into very, very deeply. But this, I'm telling you right now, probably was a liver. All right, that's what I would take from this, because it's basically solid metal. And there's your artery and vein. All right, I have shown you blood in meteorites, iron meteorites. That's a lung. These are hearts, both Bennu and Psyche. That is a heart on Earth, which is an opal heart. Here's those chambers right here, you see them? And then you get into the guts, the bucket of blood, which is inside the heart. And then we can see all the transition metals. You see these colors here? These are the transition metals I'm talking about. And this is what we're going to find, because this is part of the aqueous solution that does what they pick up and deliver things in the body using these oxidation states. You don't have to know a whole lot about that. It's just, remember, these are the things that are in the blood. They have all different colors. And they have a lot more colors than this, because sometimes some will mix together with other ones and they make spectacular colors. Now let me show you a heart, an opal heart. Now opal does a very strange thing. Right? And here's the heart, which is opal. Here's those chambers. And there's all those colors. And you say, well, why are those colors collected in these specific layers and these areas? Why is it this color here and this color here, which is very similar? And why is this all these little colors here? And why is there a big red ball there? And why is there all these different colors down here? What is going on? That is one of the tubing. They don't pick up the color. The actual tubes don't pick up the color quite the way that the other flexible parts do, because they're doing a lot of mechanical action. Now, this has to have a certain molecule attached to it to become stable. That's the key here. It's all about stability. What do I need to become stable? I need a blue guy. I need a red guy. I need a green guy. I need this exact molecule, whatever it happens to be. It could be copper, I don't know. But whatever molecule comes through here and invades, it attaches to there and it changes to that color, which is the transition metal color that we saw in that transition metal chart. But this, in opals, we have a whole different situation. We got a ton of silica, because this is all silicon, with these tiny little attachments of transition metals for stability. Some kind of special chemistry happens in opal. I really haven't figured it out, but it's extremely aqueous, meaning very, very watery, extremely heavy with silicates. Extremely heavy with silicates, and extremely heavy with blood, and then extremely heavy with clear water. And that's all I can take from this, because I also have a heart here. This is a heart. That's the chamber right there of the heart. And this, I'm going to show you what a heart looks like. That's the ventricle wall. And this is all the plumbing of this heart, but it's this turned 100% to silica. This is what they call water opal. This is blood opal. I call it that, and nobody else does. Now, this has a taste of blood left, just a taste, from one of these valves that was the red blood valve. Now, let me show you this in the actual heart, that particular line, and of course you got the aorta and so forth. All right, this is a really cool shot. Sometimes they will break right like this, and you'll see all these different chambers. Now, this is that water opal. You see that? That's this right here. And then this right here is this. You see that's a different texture there? And then this right here is where the aortic valve went up, and the mitral valve went down, and these are like heartstrings inside there, and that's what this is. It's a heart, but it turned all completely crystal because it was in a condition where there was very, very little transition metal. Somehow, the reason they ran off. Now, I have another heart here that I cut open that shows all of the stuff inside, all of the little heartstrings and all that stuff. Hold on. All right, don't forget, this is a complete heart, and that's the big valve, or the big plumbing up there, and this is this right here. All right, and then inside is all these little heartstrings. That's what's inside a heart. Now, I had another one here. It is. This one here is another water opal heart, and I cut it open, and it's virtually identical to what's inside of here. All right, it's all that webbing, which is your heartstrings. Now, you saw those hearts in space. They're absolutely gigantic. And when I show you Comet 67P, you're going to drop to the floor. I have these on my property. I have giants, and I have them DNA tested, and they're human. This was not DNA tested, but I have a giant fingertip 3 feet long, one fingertip 3 feet long, and that was DNA tested. It still has its fingerprints and fingernail on it. Now, this is a hair follicle, huge. It's even from a creature bigger than that. You see that? That's where the muscle attaches, right there. Right there. You see that? That's where the shaft comes up through the top. That's the hair shaft right there, coming right up. And this over here is the sebaceous gland. You see it? You see that? So we got the muscle here, makes your hair stand up on end. We got the sebaceous gland here, which oils the hair. We have the root coming down here, which is the root ball. We have the vein and the artery, those two little dots right there. Now, this turned solid in some other condition. But all this stuff, I believe, all the things I have here, 100% of them, were from the Great Flood, which didn't happen that long ago. All this stuff is on the surface of the earth. Nothing even was hardly buried. Most of it I just picked up. And I found new species, which have the toes built into them. They're almost like a human being. The tibia comes down here, the bone. The fibula comes over here, which is the second bone. They just fall off because they're only held on by some ligaments. And the rest is just like a foot. It's just like a foot. Only inside there's springs. You see these? There's springs inside of them that act like they give us some kind of locomotion. I don't know. We have other ones that are very similar and have the springs eroded so you can actually see them. I have so much stuff here that it would take, well, it's taken years, 10, 15 years now I've been showing it. And I show a lot of new stuff. I show the old stuff too because I can easily show that is from a gigantic creature. Now, I don't know what kind of creature it's from. Could be a human, I don't know. I imagine you could get DNA out of here because virtually everything, when you drill deep inside of it, they're just saturated with blood. I mean, it's literally saturated. You can't believe it. Even like rocks. You see this rock right here? You look at that rock and you say, that's just a piece of sandstone. Well, I'm going to tell you what this is. That was a toe. And if you knew how to look at this correctly, you could easily understand what you're seeing here. You see the blood here? Well, right, when I say blood, you see the green growing here? That's growing in red blood, which is still in this rock. I don't feed it water or anything. It just grows out of there. And that's where the bone was. You see that round spot right there? I know, it's crazy. But that's where the red blood was, and this side was where the black blood. Black doesn't grow anything. The red blood turns everything green. Red blood they sell blood meal. And the blood meal makes things grow green like absolutely amazing. And it died laying flat like this. And here's it's still growing out of here. And I have other ones, the same thing. They have, wherever the artery was, things grow out of there. This has been sitting around here for 15 years in my shop. I've never put a drop of water on it. Now, you would not think about this being a fingertip or a toe unless you thought the way I think, and I can see, I know what it is. And that's the bone right there, and that's the artery, and this side will be the vein. All right, this is Bennu where they took their sample, and this is blood. And this, I will show you, is basically the exact same thing you're seeing here, colors and everything. And this is as it goes down into the lung. That's the heart, but this is a lung. Not a whole big difference. You see that? Now that's Bennu. Look at this stuff. Now this is the one, my iron meteorite I have here in the shop. I put a little moisture on it. So, hold on, let me focus this in. You see that? That's red blood. This is the tissue that is and you see these little white fibers in there? That's the tissue that makes it be able to, go in and out, because this is a lung. And I'll show you one here that I have DNA tested. It has the same fabric, only it's not burnt up like this. Now, if you look at this, look at the blood and the black near around it, and look at this. Virtually the same thing. Now this cooked in space, this cooked, the one up here, cooked coming through the atmosphere, and it still has red blood in there, and the blood is still active with the enzyme catalase. If you put hydrogen peroxide on a blood vessel and on blood of any sort, it will foam up because it has extra oxygen, and blood says no more extra oxygen in here, and it bubbles it up right away. Now, the stuff they brought back from space is going to probably not have a lot of catalase, because catalase is a very, very complex enzyme, and all you have to do is break a couple of little bonds and it's done. I'll show you what an enzyme looks like and why it probably wouldn't survive space well. This did because after a little while when you put it on there, it gets way down inside and then it bubbles up because the inside blood, these rocks have tons of blood inside them, absolutely saturated with blood. All right, this is the clincher right here. This is comet 67P. The beauty of a comet is when it gets close enough to the sun, it gases off. And you see, what does that mean? They always thought it was just dust from the solar wind. No, it's not. That is gassing off. All right, and what does gassing off mean? It means it's sending out moisture, literally. It's cooking. It's literally cooking, and this has to be saturated with fluids and blood, just like it is in a body part. In space, they don't lose all this until they get close to the sun. Now, Psyche is burnt up. Now, how that happened, I don't know, but it is literally smelted, and if it's an asteroid, I can't account for it. But this is an artery, huge artery, huge. These are little blood vessels that come up to service the tendon. All right, you see them spouting off this way and this way and this way and that way. That's because they're being cooked by the sunlight. It has to hit exactly correct to make them gas off, to burn, just like in your gas grill. Now this is also 67P. This is the ball at the end. The stalk comes out. These are tendon fibers, and this is a bundle of, it probably is muscle. It might be tendon, but I think it's muscle. And all of this debris down here is just eroded blood tissue and bodily tissues and fluids. And this also, they tested this. They landed a lander on there, Philae lander from the European Space Agency. And they found that, yeah, it's just nothing but organic. Same thing. They only tested for a few things, but they tested a whole batch of different oxidation states of iron, ferrous oxides, and they were all over the ballpark, which is what happens in your body. Your body uses oxygen, and it creates iron oxides. All right, so some have Fe2O2, Fe2O3. One of them has 2 oxygens, one of them has 3 oxygens. That's how carbon dioxide works, all that stuff. And it was all found there, 100% biological. Now that's 67P from a different angle. And it's a hip joint. It broke off at this part. Sometimes they break right off about here. Sometimes the ball is left here almost like a ball. And sometimes they break over here. This one has the hip joint and broken off right there. I don't know, you know, from giant creatures. There must have been battles in the heavens and they just exploded them. You see that? That's the artery that I showed you, that big, huge column of stuff coming out. All right, this is that gigantic artery with huge gassing off. It's 500 feet across almost. It's 40 meters, is this wide. And it's like 4 times across there. And this was all that, where all that blood and gases came out of. This is a wet inside comet. And the reason we can tell is it gets close to the sun, it cooks. All right, so you know what a heart looks like. You see here? You know what a heart looks like. It has all these little chambers. One of them's going to be real red, and one of them's going to not be red, and one of them's going to be, the pulmonary valve will be almost yellow, actually. And I can prove that. Here it goes. Because this is a heart my friend found. You see it? This is where the red blood is. This is the sort of not red blood. And then this is the pulmonary area where it's the vein. It has no more redness to it because there's not the extra oxygen makes the red. Now, he saw this rock, and he saw this little red spot, and he hit it with a hammer, and it broke right, zip, just like the plumbing came right off the top. And here it is right here. It's just solid red blood in there. Now, this was after a couple of hours. Hold on. Where did he go? Phil, where are you, buddy? All right, here it is. You see, here it is. There's the pulmonary area where it's the blue used up blood, and this was where it was just totally saturated with red, and now it's turning black. That's what happens when they get into the atmosphere. And out in space, we're going to see mostly that. We're not going to see a lot of red blood. And there's going to be some changes, molecular changes, because of the radiation primarily. But they will be pretty much saturated with blood like this. I can't see them having lost a lot of blood, because I have one here that came through space, and it was actually saturated with blood, and it had so much blood in it, it exploded. And I'll show you that right now. But don't forget, that's the blood after an hour or two sitting around. And prior to that, it was just saturated with blood. And then now this is turning black, see? That's it. Oxygen is a very reactive molecule, or, atom. All right, here's another comet called Hartley. And the same thing. It was pulled out of some kind of a socket. It has a neck on it, and it's spewing off all different directions because it needed to put blood on there. It broke the bone off or something. I don't know what it is, but it's another body part. You see that? That's 67P on top of Raleigh, North Carolina. Look at the size of the thing. I mean, it's just absolutely stunningly large. That has that 500-foot artery. Now, there's all kinds of creatures. They were our size. They had lungs just like ours. That's almost identical to the same size of a human lung right now. And it still has it's saturated with blood, absolutely saturated with blood. And so will all these things in space be. So I expect there's going to be a lot of moisture. There's going to be all these transition metals and stuff you could grow food on, because blood is the thing that makes everything grow fabulously. You put blood meal on something, that will grow very, very nicely, very green. Blood meal, bone meal, and feather meal. Those three things make things grow like crazy. It's all biological. And these are biological parts. I don't think anybody can stand up and contest this now. If you look at all these things I have just shown you, and you missed what I have shown you, I want to know why. What did I not express to you correctly? And can I show this is actually a hip joint? I basically can. If you look it up, you'll see it comes down. And again, sometimes they break here, sometimes they break way out here. And this one broke way out here. See, this is a hip fracture. Sometimes they break right here and you get this. Actually, sometimes they'll actually break right like this too. And then the one we see for 67P is this one right here, fractures here. Now, it might have fractured like over this way. They break in all different ways, but there are some weak spots that are primarily where they're going to find them. And then they tell you how you're going to fix this. And this is about hip fractures. All right, I have the lung here in the microscope, and I'm going to put some hydrogen peroxide on there. Now, I'm just on the fabric. This is where the red blood is. But let's see what happens on the fabric. So here it is right here in the microscope. All right, now let's put a little hydrogen peroxide on there and see if we can see any reaction. All right, we should see a lot of bubbling if there's blood present right in there, because the blood will have the enzyme catalase. Now let's see if we can see some. We should see some. Not a lot. You see a little tiny bit. Wherever you're going to see a lot of red blood, like you see it coming out of that hole right there, there's red blood down inside there. Wherever the red blood is, you're going to get the bubbling. And you're seeing a little here, a little there. But you only pretty much see it where there is blood, and where there's a lot of blood, it really foams up. So you can see there's very little reactivity on the surface of this lung until we get to where the blood is. Let's see where the blood is. All right, same lung, but now we're down where the latch is, where the red blood is. And this is where there's a lot of red blood here. Now let's try a little catalase here and see if we see a reaction. All right, let me get some catalase going. I'm sorry, hydrogen peroxide is what you put on here, and then you look to see if you have any bubbling. Bubbling indicates the presence of the enzyme. And if the enzyme's there, it means it's actually blood. All right, now it might take a while. I can start to see some bubbling over here. Let me focus down in there. It's bubbling and you can't see it because I got to get real close. Hold on. All right, so you should be able to see these foaming up bubbles here. That indicates everywhere you see these bubbles, that's reacting with a catalase enzyme. And the enzyme is saying, no more oxygen down there. We don't let extra reactive oxygen species inside our blood. This is all biological reaction. That is right there biology, my friend. That is just nothing but biology. You see it bubbling out of here? All right, when we just put it on the surface, if we don't have a lot of blood, and in this area over here where there's not a lot of blood, here, well, you can see it, it's just red blood. And it'll just keep bubbling away, trying to get rid of that extra oxygen. That's what catalase does. Now, my iron meteorite has catalase in it. So as far as I'm concerned, it's still got red blood in there. All right, if you want to read this, you could. It's a role of catalase in oxidative stress. That means getting rid of the extra oxygen because it's very reactive. So it gets rid of reactive oxygen species, ROS. And it goes through a whole big thing about... Anyway, I just showed you it actually working, and that is an enzyme, and you don't get that kind of enzyme without a bacteria creating the enzyme. Very crucial that you get this bacteria to create the enzyme. Here's the enzyme. All right, I just want you to understand this. Catalase is one of the crucial antioxidant enzymes. Where do enzymes come from? All right, listen to this. What are bacteria, enzymes, and chemicals? Bacteria are living cells. They're little single-celled living little creatures that are inside of you. They have a capability of consuming waste, eating up waste that's destroying your body, reproducing so they stay alive and they continue to do their job, and actually producing enzymes. Better said, bacteria are the factories that produce enzymes. Catalase is a critical enzyme. You need a factory produce it. What is the actual bacteria that produces catalase? I don't think they know. The enzymes are not alive. They're squirted right out of the bacteria to go out as a chemistry set to destroy things and create and do all kinds of things. All right, as you can see, I go very deep, and I provide support and evidence for every single word I say. Now, I told you that bacteria create the enzymes. Yes, they do. These are ribosomes. Ribosomes turn into the enzymes. And what do the enzymes look like? This is what enzymes look like. You see that? That is the most elegant looking thing you've ever seen. And all of these little tags have to be in the right spot to do that particular job. And when it's right, boom, it does it. It creates millions of chemical reactions per second, which it would take years to do if it wasn't for this catalase or for enzymes in general. There's thousands of different enzymes in your body, and they're just starting to look at them in a new light. They didn't realize bacteria was as important as it is. And now they realize your gut microbiome is basically almost your entire immune system. And these things float around through a fluid-filled highway, these enzymes and bacteria, and they protect you by protecting the membranes. They float around through the membranes. All new science now. All new. The truth is, this was just literally discovered a few years ago. Interstitium is this highway, this fluid-filled highway where all of these enzymes go and the bacteria. They never knew it was here. It says, with all that's known about the human anatomy, you wouldn't expect doctors to discover a new body part in this day and age, but now researchers say they've done just that. They found a network of fluid-filled spaces that hadn't been seen before. It's this fluid-filled highway. That's where all these microbiomes and the enzymes and the bacteria live, and they protect the vital flesh from invaders. You can get invaded here. It's not going to be the end of your life. But once it gets down in here, then you got an issue. And if you don't have the things to protect you, it's going to get through there. Also, if you don't have the enzymes in here, in your gut villi and so forth, which is inside your intestines, you can't break down the food. You can't break down the food, so you can't get the nutrition you need. So you're either always perpetually hungry or tired, or you're getting invasion, or you're getting inflammation. This is the key to health right here, and they just discovered this just recently. Okay, so as I said, I'm willing to bet money on it that what is going to be found in that Asteroid Bennu will be precisely the blood chemistry that I talked about, because it is a heart. Very, very obvious for anyone that looks at this with a good open mind. Can't miss it. And lungs too. The heart, lungs, liver, fingers. I mean, it's all stuff in space. They talked about battles in the heavens. I cannot dismiss it. I love you all. Think about this deeply. It has a big impact on our lives in every single sector. Now, you may say, well, what can I do about it? Well, I don't know. Maybe you could change things a little bit. Maybe not. It's up to you.